Hi everyone, this is Navika, cloud engineer and a Microsoft Most Valuable Professional in Azure. I warmly welcome each one of you to the 27th episode of Tech Chat with Navika, wherein today we would be discussing Azure Kubernetes services. And for that, we have a very prominent speaker with us today, Sam Cogan. Sam is an extremely experienced professional with over 25 years of extensive working experience in the IT industry. He's currently working as a solutions architect at WTW with a mission to drive innovation through designing and optimizing the cloud infrastructure solutions, specially centered around Azure. In addition to that, Sam is a Microsoft Most Valuable Professional for over 7 years consecutively and has been significantly contributing to the tech community in an impactful way. He specializes in cloud first and cloud native infrastructure, which includes containers, Kubernetes, serverless, and everything in between it, and as well as infrastructure as a code. Thank you so much, Sam, for taking out your precious time and joining me in today.
No problem. Thank you for having me.
Thank you so much. And I cannot wait to get started with this podcast. So, to quickly set up the agenda for the next 20 minutes for the viewers, we are going to be diving deep into the topic of Azure Kubernetes services. As I just mentioned a couple of minutes back, we would be discussing its basics, application deployment, managing and scaling AKS clusters, the best practices to ensure the security of AKS clusters, and then we would be diving into the advanced features and its integrations with the other Azure services. But before we dive that much deep, in order to get started with the podcast, I would like to start with a brief question. That is, Sam, what do you think is Azure Kubernetes services? If you can give some brief overview of AKS, and what do you think is its significance in today's application development landscape?
Yeah, sure. Yeah, so AKS is Microsoft's implementation of Kubernetes in Azure, and it's been around for a good probably 5 years or so now. It's kind of an evolution of the implementation of Kubernetes. So if anyone remembers back, originally there was a service called Azure Container Service, or something similar. I can't actually remember the exact name now. But in the original implementation of that was essentially a set of infrastructure as code scripts that you ran to deploy a Kubernetes cluster into Azure. And then after that, it was kind of down to you. So it deployed a lot of VMs and configured them for Kubernetes, and then kind of left you with it to manage. It was a very much an infrastructure as a service offering, and it was fairly difficult to manage. And so AKS was an evolution of that, where instead of being something that you deployed on VMs, it deployed a properly kind of PaaS solution for Kubernetes, which allows you to have a lot less management overhead, although it's still fairly significant, to deploy Kubernetes clusters. And it's evolved over the last few years, adding lots and lots of new features to support everything that Kubernetes does, as well as bringing in a lot of the third-party components, such as network overlays, service meshes, all those sort of things, to allow you to run a Kubernetes cluster without having to understand all of the underlying bare metal implementation of Kubernetes. If anyone's ever tried deploying Kubernetes from scratch, or as defined as a Git repo called Kubernetes the hard way, which is deploying everything on bare metal, it is a very complicated solution. And so AKS allows you to create a Kubernetes cluster with a few clicks in the portal or using the CLI, and get one up and running, so you can then deploy your applications onto that and really focus your effort on getting your applications running rather than the underlying Kubernetes environment.
Great. Thank you so much, Sam, for that answer. And that also helps us understand the use cases of Kubernetes as well, AKS as well. Now that we have a basic understanding of what AKS is all about, would you like to take us through the fundamental components of AKS? And if you would also like to cover the different steps that are involved in sort of setting up the AKS cluster.
Mm-hmm. Yeah. So if anyone's familiar with Kubernetes, you've got two components effectively. You have the Kubernetes control plane, what used to be referred to as Kubernetes masters, which are the piece of infrastructure that actually manages where your workloads are deployed, where they're running, scheduling services, all those sort of things. And then you have the worker nodes, which are the ones that actually run your applications. And so when you deploy an AKS system, you get both of those things, but they're configured slightly differently. So the actual control plane is something that's completely managed by Microsoft, and you don't really see any of the infrastructure behind that. That gets deployed as part of the actual creation of the Kubernetes cluster. And then you have your worker nodes, or pools, as Microsoft refers to them, which are the actual resources that your applications run on. And for those, you do see a bit more of the underlying infrastructure. So when you create an AKS cluster, one of the things you do is you tell it what type of worker nodes you want, and they are based on the standard Azure VM sizes. So your DV4 machines, or whatever sizes you want. And so you are selecting which size of VM you want and how many of them. And that also then factors into the billing when you actually pay for Kubernetes. The control plane piece is either free or a very small amount if you pay for the supported version. But the actual main bulk of what you pay for when you deploy AKS is the nodes, and they are effectively billed as virtual machines. And when you deploy them, what you actually see in the Azure portal is you will see it's actually a VM scale set that gets deployed with those worker nodes. And so it's there's a little bit of an IaaS element there, except for those scale sets are actually really kind of mostly managed by Microsoft. You can still fiddle with them if you want, but you kind of advise not to. And they are what run the actual worker nodes, and you can have various different worker pools with different sizes of VMs. Maybe you need a pool that has GPU-based capabilities. Maybe you've got some that have high memory. You can mix and match and have different worker pools that run your nodes. And so when you deploy a cluster, those are the two things you get. And if you deploy the basic, a small cluster tryout, you will have one node pool with a minimum of one VM in it. And then you will have the control plane that actually is managing all of that. And at the end of it, you will also then get a load of other resources, such as like a virtual network and some network security groups and so on. You can either have those configured for you, or you can define your own and get more complicated and sort of customize everything if you want to. But that's effectively what happens when you first deploy it, is you get those resources that are running. And at that point, you are then able to connect using the command line, the kubectl command line tool, to your Kubernetes cluster and actually then start working with it.
Right. And also you mentioned about like a minimum of one VM is something that needs to be deployed. But from that perspective, just trailing question to it, how does the costing of AKS sort of works? Is it like directly proportional to the number of VMs deployed in the cluster?
Yeah, so for the most part. So I mentioned that the control plane is free in the generic, in the sort of the basic version. You can elect to pay for the control plane, which gives you additional support. So if you use what they call the standard SKU, you get some additional high availability components added to it, and you would get an SLA for that. If you have the free version, because it's free, Microsoft can't offer an SLA because they can't give you any money back if it doesn't meet the SLA. So the free version doesn't really have an SLA. It has a target, but it's not the same, so it's not backed by contract. So that you may elect to pay for the control plane. And it's a fairly small amount, it's a couple of $100 a month, I think, something like that. The vast majority of the cost is going to be the cost of the nodes that are running your workloads, and they are just the VM cost. So you can go and you look them up on the calculator, and they will just be the same cost as if you deployed just a virtual machine for you to run Windows on or whatever. And you will pay for them. So if you put 4 D4 V4 ones on there, you will pay for 4 of those nodes for as long as they are running. And there are obviously things you can do to reduce that cost by doing sort of auto scaling, by changing the sizes of those and so on. But effectively, that's where the bulk of your cost will come from, is the amount of nodes you have running.
Basically, the compute cost. I got it.
Yeah.
Great. Thank you for the detailed explanation. And now that we have covered the setup of AKS cluster, moving on to the next section of our podcast, that is application deployment. So how do you think the applications can be deployed to AKS? And also, if you would like to explain a bit about Kubernetes manifest over here.
Yeah, sure.
This entire process.
Yeah, so once you get to the point of deploying applications, you're kind of leaving the Azure ecosystem at that point. So there are some tools, and we can talk about those in a minute, that kind of help you with that. But effectively, what you're doing at the point of deploying applications is you're running those applications on Kubernetes. And the fact that the Kubernetes is kind of deployed in Azure and AKS is mostly irrelevant at this point. You will use the Kubernetes native tools to do that. So for a very, very basic setup, you can just use Kubernetes manifest files, YAML files, to define the kind of resources you want to create. For those not familiar with Kubernetes, generally what you will run is a pod, which is a container running inside a sort of wrapper. And you would then have some things like services around that, which help you load balance across them. You would maybe have some ingress to direct the traffic from the outside world, things like that would allow you to then deploy those onto Kubernetes. So you could do that using plain Kubernetes manifest files, and you would deploy those using the kubectl command line tool. You can get a bit more advanced, and you can use things like Helm, which allow you to wrap up those manifests into a zip file package that you can then deploy, and you have sort of package management abilities around that. And that's probably one of the most popular ways of doing Kubernetes deployments is through something like Helm. Or you can go a bit further, and it's kind of what the real popular thing at the moment is to look at using a GitOps-based approach, using some tools like Flux or Argo CD, which allow you to define your Kubernetes manifests in a Git repo, and then you have the Kubernetes cluster as kind of reconcile against that Git repo. So if you make a change, if you need to deploy, let's say you want to deploy a new pod, you would write that manifest as either a plain Kubernetes YAML file, or there are a few other methods you can use to create them with Git flow, and then you would GitOps, and then you would commit that into your Git repo, and the Kubernetes cluster would realize that there is new changes been made, and it would try and automatically reconcile that. So it would pull your code from the Git repo for you and run it, and that would deploy the new pod or whatever you asked it to do automatically for that. So you're not, at that point, you're not having to do much involved with the cluster. You are writing some manifests in YAML, putting them into a Git repo, and then that's automatically deployed for you. So you can kind of get as complicated or as simple as you want. I mean, you can even go into the command line and just write kubectl commands that will create a pod directly, but not many people are looking to do that in production. So generally you will have some sort of manifest, but it depends how complex you want to get and how involved in your deployment process you want to do.
That's right. Thank you for explaining the detailed process. And once the application has been deployed to AKS, I think one of the most important aspect that comes into the picture is managing and scaling the entire AKS cluster. So in your opinion, how do you think that AKS handles this scaling, and especially if if you would like to give some best practices for managing large scaled AKS deployments?
So there's a few things we can look at in this area. So obviously one of the things is how you scale up the Kubernetes resources and the infrastructure behind that, and potentially even doing that on demand. So it's very common to have multiple instances of a pod in Kubernetes to handle workloads, and to be able to spread those workloads across multiple pods for your application to be able to survive one of those pods going down, or infrastructure problems, and so on. And so there are a few concepts you can manage that through. So the first is you can actually scale the pods within Kubernetes, and you can do that either yourself. You can define how many pods you want when you deploy them, or you can define an autoscaler within Kubernetes that will scale up the number of pods based on traffic, or the number of requests in a queue that's being serviced by your pods, or any number of metrics. And there are few tools out there. A very popular one is one called Cada, that will allow you to sort of scale those pods based on very complex mechanisms if you want to get really complicated scaling on there. That will allow you to scale up the resources within your cluster, but obviously there is a finite amount of space on those virtual machines that are running your worker nodes, and eventually they will get full. And so another thing you can then do is use the node autoscaler within Kubernetes that will allow you to actually add more nodes when you start running out of space. And Microsoft has an implementation of that with AKS that you can use that will scale up the scale set and add more nodes and reduce the number of nodes when they're not in use based on some uses characteristics as well. And so that kind of allows you to scale at both levels, at the application level and then at the infrastructure level, to manage that. Obviously, when you do that, you can start adding more nodes, you start getting more cost. If you've got a very big application or you've got lots of applications that are running those clusters, you can start getting very large clusters. You can add in the fact that maybe if you want to add some sort of disaster recovery capability, you might end up with a cluster in another region. Maybe you've got customers all over the world and now you want multiple different clusters in different parts of the world and so on. And you can start then having difficulties managing some of those very large clusters once you get to that point. And so there are a few things I wanted to mention that can kind of help in that area. So the first one is something that's it's in preview at the moment. It's relatively new, but it's something called AKS Automatic. And so this is a new deployment method for AKS. So when you deploy AKS, there are lots of different dials you can turn and levers you can pull to turn on different features and capabilities. And some of those are kind of things that everyone will use. Some of them are very niche for certain scenarios. AKS Automatic is a means of deploying a cluster that is kind of configured with a lot of those best practices already enabled. So it will turn on a lot of features that Microsoft kind of think everyone should be using these sort of things, and with a lot of automation in place to kind of deal with a lot of the management for you. So to give you a key example, AKS comes with the ability to do automatic updates. And so it can update both the OS patches and also the version of Kubernetes. The default version you get doesn't have this turned on, but if you enable AKS Automatic, it configures this all for you. So it's turned on, it's configured for to work with certain update paths, so it updates on the latest major version of Kubernetes and so on, and it sets all that up for you, so you don't have to do any of that, and your updates are all managed for you. Similarly, it deploys some resources that are kind of best practice that you might not do if you weren't thinking about it. So, for example, you get for the networking, you get the Nginx application routing, and you get the virtual network set up for using the outbound VNet gateway. All those things are kind of configured for you, and so it makes the deploying of a cluster that's already configured for best practices and meeting certain standards very easy, because you just say use AKS Automatic and it'll do that, and it will also then take away some of your management operational overhead as well. The second thing I want to mention is something called Fleet, which is a management tool that Microsoft have released for managing multiple clusters. So you can deploy this Fleet solution, which in itself runs on AKS, and this sort of central management service. You then add all your clusters into that, and it will manage things for you. So you can look at things like scheduling updates over multiple clusters. You can look at application rollouts over multiple clusters using this tooling, and you can just get a single pane of glass that allows you to see what's the state of all your clusters are in, and then manage those clusters from a single place. And then finally, you kind of bring into that some of the monitoring capabilities that Azure has. So things like App Insights, Azure Monitor will allow you to bring in a lot of those metrics and monitoring for those clusters into a single place. So you can have all of your metrics in a dashboard for all of your AKS clusters, and you can sort of bring that into one place as well, which will help you manage all of those clusters in a single view.
Yeah. Thank you, Sam, for that answer. And also thank you for giving such an informative answer to this question, and also covering the strategies for auto-scaling as well as for its integration with the monitoring tools such as Azure Monitor, as you just mentioned towards the end, from the performance perspective. Now that we have covered actually all the different sections, we literally started from the basics of understanding AKS, moving ahead with getting started of it. We have covered the application deployment and the management and scaling of the AKS clusters. And now that we have almost reached towards the end of the podcast, one of the last questions that I would like to take is from the security perspective. As we are aware that security plays like one of the important pillar in general to an Azure architecture. So, if we see from the security perspective, how do you think that the organizations who are running their applications on Azure Kubernetes services, how can they ensure that their AKS clusters are well protected? So some of the best practices from the security perspective that one can, sort of put in the infrastructure.
Yeah, sure. So there's kind of two views of this. There is the management security and then the actual application security. So if we start with management, you need to you need to be able to administer these clusters and connect to them to do whatever management task you want. But you want to make sure that's done in a secure way. So there are a few things that are kind of required, really, I think, from when you deploy these clusters. So first up, you want to enable Entra ID authentication on your clusters. So there is, back in the old days, Kubernetes has its own authentication mechanism built in, and you could use that. But we're kind of moving away from that now and want people to authenticate with their Entra ID identity, so that they're using the same identity they use for Azure. They get multi-factor authentication, conditional access, all those sort of things. That's turned on by default, I believe, now, but you want to make sure you configure that. You also want to restrict access to the actual management API of the cluster. And there are a couple of ways you can do that. The easiest and the sort of basic way to do that is you can define an IP allow list on the management interface that says you can only connect to this from certain IP addresses. And that's very, very easy to set up. If you want to take it a bit further, you can enable private clusters, which then use private endpoints to actually configure that management access. So you can actually only connect to those from certain networks where your private endpoints are configured and the management plane is completely not open to the internet. And that's probably a more secure option. So you probably want to look at using one of those two options just to lock that down. Then looking at the application side of things, you obviously are going to have people bringing traffic into your cluster to actually access your application. And there are a few things you're going to want to kind of put in front of that traffic to make sure that you are doing that securely. So the first thing is if you are bringing traffic into the cluster, generally you're going to want to add an ingress option into Kubernetes. And for that, you're going to need an ingress controller of some sort. So that might be something like Nginx. It might be something like Istio with a service mesh, or it might be something like Azure Application Gateway, which has direct integrations with Kubernetes. Whatever it is, you want to make sure that kind of is providing a lot of security services for the traffic that's coming in. It's going to want to control where the traffic's going inside your cluster, but also potentially you could add things in there like web application firewalls, IP restrictions if you want to go down that route, even some levels of authentication. Some of that, if you use something like Nginx, you're going to have to sort of code into the manifest you use to deploy on that. If you bring in something like Application Gateway, then some of that can be handled via the UI or even by your manifest as well. And then maybe even you want to layer on something like Azure Front Door on top of that to do. Again, it could do web application firewall, but global distribution and those sort of things as well, so that you've got some sort of protection for traffic coming in. And then also you could introduce something like API management as well if you wanted to go even further and have some of the rate limiting and the transformations that API management offers, as well as perhaps doing some of the authentication and authorization piece as well. So you've got multiple layers there you can sort of put on top of your application to secure traffic that's coming in.
Awesome. Thank you, Sam, for explaining both the size, the application and in general, and as well as explaining the different layers of security. Really appreciate that. And this brings us towards the end of our podcast. Thank you so much for such an informative and educative podcast. I'm sure the last 20 to 22 minutes would be really informative for the viewers as well. And as we are ending with the podcast, any ending note you would like to give to the audience?
I think the only thing is that AKS is a very powerful service. You can do an awful lot with it, but it brings its own complexities. So it's something that you want to perhaps make sure that you're investing the time in to learn if you're going to go down that route. But also, if you are looking at containers, but you perhaps don't need the complexities of AKS, which can be a big learning curve, there are other services like Azure Container Apps, container instances, and so on that actually might offer a simpler solution as well. So have a look at what's available and pick the right tool for the job, rather than just jumping in with Kubernetes, it's a great tool and it's a lot of capabilities, but it is quite a steep learning curve.
Yeah. And in fact, also, I would recommend for the people who are new to it and someone who has basic knowledge as well, they can hover onto Microsoft Learn. There are a lot of learning paths and modules on Azure Kubernetes, and all the different ACI and all that Sam has mentioned. And also we have covered ACI and other services in my previous podcasts as well. So, in case you would like to get some more knowledge about it, feel free to hold on to the respective resources. And yes, thank you so much, Sam, once again for joining me in today. It was my complete honor and privilege to have you on the podcast. Thank you so much.
No problem. Thank you for having me.